Good morning, everyone. So today's main lesson is us trying to deal with x squared problems. So in algebra, our goal is to be able to solve for x, and x could come from any direction. It could have a square, it could be multiplying, dividing, adding, it could have 10,000 things to it. And our goal is to have a process, a list of steps in which we can isolate our x. So let's go back and talk about how to solve for x from before. Solve for x. Okay. This is a very algebra 1 topic. And when we're solving for x, let's say if I say 3x equals to 12. There's a couple ways of solving for it. You can guess check and guess, oh, that could be a 4. 4 times 3 is 12. And you'd be absolutely right. But in algebra, our goal is to learn processes so we can do this without having to guess and check. Because guessing and checking for difficult problems are impossible. What if the answer was a decimal fraction? Okay. So we use our process of opposite operations. The opposite of multiply is divide. And that's a process that we learned in Algebra 1. These processes don't change. If I say if dividing x divided by 5 equals to 2, right? So what number divided by 5 would be 2? You're probably thinking in your head already, 10. Well, if I do opposite operations, opposite of divide by 5 is to multiply by 5 to both sides to be fair. We end up with x equals to 10, which is what we were saying. We learned a bunch of other processes in Algebra 1 besides multiplying and dividing. We learned addition and subtraction. Those are some basic ones. And we also learned how to solve for a square. Now, if I give you the problem, x squared is equal to 4. I want you to first do what we were doing, guess and check. Guess a number that when I square it would equal to 4. And then guess the other number. You probably were going to say 2 squared. And some of you guys might have said negative 2. And those are both absolutely right. Because if I take 2 squared, that's 4. And negative 2 squared, that's also 4. Right? Now, our process, the opposite operation for a square is a square root. So if I write x squared equals to 4, and we take the square root of both sides, there's a couple of tricks that we need to remember. First, if I go ahead and solve it as it is, a square root takes out a pair, and we do have a pair of 2's. Oh, sorry, a pair of x's. So that's just x equals to 2. But the idea of algebra is to solve for all the possibilities. Don't just give me one and make me guess if that's the right one. No, the goal is to have every answer possible, and it's a guaranteed answer. Now, what people said is that in order to fix this dilemma, because my answer is 2, but we also need a negative 2, right? We also need this one. We include a plus and minus every single time we take the square root of something. If I am actively taking a square root of something, if I write the square root in, I have to write plus and minus. If I walk into a room and it says the square root of 4, this isn't plus and minus 2, this is just 2. So again, the difference is if I actively write a square root, I need to include a plus and minus. And that covers both possibilities. Why do we need to cover both possibilities? Is because the square x squared, if I say negative 2 squared, negative 3 squared, negative 5 squared, what does that do to my negative sign? It gets rid of it. So when you square something, you lose information. You lose that if it's a plus or minus originally. Sure, maybe it was a plus, but if it was negative, we would never have known. So in algebra, we want to make sure we catch all possibilities. That's why we have to include a plus and minus. And most of you guys probably remember that now. If we give you guys another example, x squared equals to 25. You're probably thinking the answer is 5 and negative 5 now, right? So the process is to get rid of the square. We take the square root to both sides, And when you write a square root symbol, see how I wrote a square root? That means you have to write a plus and minus in front because you want to cover both angles. You're not sure if it's a plus answer, you're not sure if it's a minus answer, but know what? You're going to write them both. So x is equal to plus and minus 5. And of course, if we try to check it, 5 squared or negative 5 squared equals 25, which is what our goal was. Now, this could get more complicated. In Algebra 1, you learn the process. If I write 3x squared plus 2 is equal to 150. Wait, no, not 150, I'm sorry. 77. Okay. So our goal again is solve for x, and we do that by opposite operations. Now, the thing is here is it's hard to teach kids to do this, but with enough practice, kids finally get the idea of which term do I get rid of first? Do I get rid of the 3? Do I get rid of the 2? Or the square? Or the plus 2? Which one do I get rid of first? And hopefully you guys have been practicing this enough. We get rid of the number. In my mind, I say what's farthest away from the x. If x is your holy grail here, who do we kick out first? You guys ever watch the movie The Predator with Arnold Schwarzenegger, right? The Predator hunted, like in essence, like the weakest link up. If you're walking on a long trail, you don't take the person in the middle, take the person at the end. So we're the Predator and we're hunting for numbers. So let's get rid of a plus 2 first. Since it's farthest away, it's the least attached, I would say. Some people would say this is opposite of order of operations. Order of operations says, please excuse my dear Aunt Sally. So you work opposite. So we're going to get rid of our addition and subtraction first, then multiplication and division, and then exponents, which is actually how we're going to do this here. So opposite of plus 2 is minus 2. 3x squared is equal to 75. Now, do we get rid of the square first or the 3 first? And again, you have to practice this to get good at this. If not, it's quite confusing. Opposite of multiply 3 is divide by 3. We have x squared, and that equals to 25. And now we practice getting rid of our square. So we have to include a square root to both sides. I'm going to rewrite this as a new step for you guys. Square root, plus minus of x squared equals to 25. And the square root of a square, they cancel out. They're opposite operations. A fancy word in math is inverse operations. And that's going to be x is equal to plus and minus 5. Now, would this have worked? Well, let's try it. 3 times 5 squared plus 2. That's 3 times 25 plus 2. 3 times 25, 3 quarters is 75 plus 2 is 77. Yep, that worked. And if I try the negative version, if I wrote a negative here, that would still become positive 25. Okay. So both of those were possibilities. Now, the issue now is that what if we can't take a square root? And we'll end up with problems like this. I say 3x squared plus 2, let's say 2x. Actually, no, let's go on with this. Minus 5 is equal to 0. Okay, 3x squared plus 2x minus 5 is equal to 0. Now, in this problem, it's practically impossible for us to get x alone. So we're going to learn tools later to talk about how we can solve for this. And we're going to have tools called the quadratic formula. We're going to have tools called factoring. we're going to complete the square. We have three main tools that we use to try to solve for what we call a quadratic. A quadratic equation is a problem with x squared. Right? The idea is it's just x squared. And the quadratic formula solves quadratic equations. Now, let's look at some other ones that we probably could solve. And the big deal we're going to look at, our first step is actually solve something by factoring. Okay, factoring is one of our main goals. It's actually one of our most creative, I would say. So here's the idea. If I want to factor, remember what factoring is in algebra? It's really just pulling out what's in common. Now, here's a simple example. Factors of the number 10. What are the numbers that make up 10? 2 and 5, right? So we're undoing multiplication. What are the factors of 30? That's 15 and 2, 3 and 5. The factors of 30 are 2, 3, and 5. We're undoing our multiplication. So if I ask you to factor x squared plus x equals 0. Now this one's a huge jump from doing simple numbers, but let's do something a little easier than this. What if I wrote 3x plus 3 equals 0? So we have two problems here. I want you to factor what do you see in common on the right. They both have the number 3. So if I use the word factor, I want to pull out a 3. I'm going to, hey, you have a 3? Hey, you have a 3? You guys ever go to the movie theater and they take your ticket? Right? So you have a ticket. Oh, you have the same ticket. I'm going to take those tickets from you. If I take the tickets away from you, we have an x plus 1 left. Now, I want to make sure that you understand that this is exactly the same statement, except I pulled out a 3. I undid the 3, meaning isn't 3 times x 3x and 3 times 1 3? So this is exactly the same statement, except I wrote the 3 in front. Now, why is this important? Because we have a new rule today, and it's something that we learned in algebra. It's called the zero product property. And it's a simple property that you guys will be using all the way up to calculus. And the zero product property is so ridiculously lame that people like brush it over thinking, oh, that's obvious. But it's a rule that we have to talk about. The zero product property is that if I say 3 times 0 is what? What's any number times 0? It's still 0. And it seems kind of lame, but for our problem right now, let's look at back to our problem up here. My goal is to get 0, right? And my goal is to get 0. So 3 times what number is 0? 0. So what would x be to make this 0? X would have to be -1. Because isn't -1 plus 1 0? That's 0. And 0 times any number gives us the 0 we want. One of the tricks about the zero product property is that if your answer is 0, you have to multiply by 0. What this refers to, zero product means 0 multiplying. Here's the idea. If your answer is 0 and you're multiplying something, okay? Let's say this is 5. What does this number have to be? Blank times 5 is 0. What times 5 is 0? It has to be 0. Okay, but what if it was like a million? And the answer is 0. A million times what is 0? There's only one choice. It has to be 0. So the rule pretty much defines how we're going to do these problems. If my answer is 0 by multiplication, you see this is by multiplication, by multiplication, by multiplication, one of those numbers have to be it. Let's say you go on a date, right? And the bill comes and you're not paying. Who's going to pay? The other guy or girl. Oh, but we're going to split it. No, I'm not paying. So guess who's paying? You guys ever go out with family and the bill comes and you guys are just staring at each other? I'm not paying. So we're going to do the exact same thing for this problem over here. So we have x squared plus x. Now, do you see something in common that they both share? So we could guess a number. If I guess 0, isn't 0 plus 0 equal to 0? Huh? That's a good answer, right? And it turns out one of our answers, x is equal to 0. Yay, good job. You guessed one of them. But in math, is that our only answer here? And this is where our creativity, our discovery comes into play. And us saying, is there anything else? Is there life outside the planet Earth? Is there a way to cure cancer? Is there a way for me to play Fortnite? To win the turkey? So look here, what do we have in common? X squared plus x. And you can probably hear me, I said x. So if I factor out an x, if I divide x from x squared, how many x's do we have left? If I divide x from x divided by x is just 1. Now, I want you to look at this idea now. Is this the same statement? X times x is x squared. X times 1 is x. Hey, this is the same thing. But when we change it into a multiplication problem, we come up with a new rule. Now the rule is the zero product property. Anything times anything, one of these guys must be 0. So let's make them 0. You, sir, please stand over here. You, sir, stand over here. And I want to make you both 0. There's a story I would tell kids, is that imagine, okay, you guys know that I'm a twin, right? Oh, maybe not. If you guys had me before, you know that I'm a twin. But if you don't know that, I am an identical twin. There's someone in the world that looks like me, who kind of talks like me, who has the same exact DNA as me. So if I ever commit a crime and I leave my DNA at the crime scene, who are they going to go after? Turns out, if they think me or my brother did it, they have the ability to actually come after both of us, because the DNA says one of us did it, and I'm not copping out to it. I'm not confessing. And then what happens is they are able to run the trial, not by picking one of us, but they can actually run the trial against both of us at the same time. So I am saying, hey, you, Mr. Ko, you're equal to 0, and you, Mr. Ko, you're also equal to 0. No, but I didn't do it. I don't care. So here's the cool part. If I make x equals, each of these parts, if these factors, these are called factors, equal to 0, the left one's done already. How about the right one? What value? Minus 1 minus 1. X is equal to negative 1. Turns out we have 2 answers here. So not only 0 was a possibility, but also negative 1. And let's try it. X squared plus x equals to 0. What if x was negative 1? Negative 1 squared plus negative 1 equal to 0. Negative 1 squared is 1, minus 1. Oh my gosh. How many guys knew that negative 1 was an answer? Just by looking at it. So we're working on different ways of solving, because if you take the obvious answer, sure, but you don't end up with all the possible pathways. That's kind of an analogy to life, right? If you take out what's obvious, you miss out on the secret stuff, the nicer stuff, the more creative things. Okay, so we're going to look at the zero product property today, and we're going to look at it on an easy way. Because today I'm going to give you all the factored forms. If I say x times x minus 4 is equal to 0, what are the possible zeros? So you say take each of the factors and make each of the factors equal to, make each of the factors equal to 0. Take a look at what I just did here. I split it and said, you get a 0, you get a 0, you get a 0. Everyone here gets a 0, because I don't know who the criminal is. Not to say criminal. I don't know who the winner is, okay? I don't know who's going to win the lottery. It could be you. It could be you. Can't be both of you. So x is 0. That's a freebie. And the second one is plus 4. Plus 4. X is equal to 4. Now, this problem, if I multiply it out, is x squared minus 4x equal to 0. And how should I know what numbers will make that go to 0? Well, 0 is a freebie, right? But did you know that 4 would work? 4 squared minus 4 times 4. Whoa, 4 squared is 16. 4 times 4 is 16. And that does equal 0 too. I would never have guessed that second answer. If I switch ledgers, if d plus 3 and d minus 8, okay, what numbers will make this go to 0? We'll set them apart. So minus 3 to both sides. D is equal to negative 3 plus 8 plus 8. D is equal to 8. Turns out these are both our values that would work. Maybe some of you guys are catching a clue though, because I'm writing all this work, which is great, but you can do this mental math. What number would cancel out a negative 8? Positive 8. That would give us our 0. What number would cancel out a positive 3? Negative 3. These are my answers. So the goal of this is to eventually do this in the mental math fashion. The original problem, if I multiply these together, would be this crazy answer, d squared minus 5d minus 24. Good luck guessing what numbers will make this go to 0. But turns out negative 3 and 8 would work. Let me do the math. 8 squared is 64. 5 times 8 is 40 minus 24. 40 and 20 is 60. So 64 minus 64 is 0. Don't believe me? Let's try the next one. Negative 3. Negative 3 squared is positive 9. Negative 3 times negative 5 is positive 15 minus 24. 9 and 15 is 24. 24 minus 24 is 0. So we're working with the easy structures before we get to the hard structures. And hopefully you remember this from algebra, how to factor. If not, we're going to reteach it. Okay? So the goal is for today, identifying values that make this go to 0. Now let me just do one more. If I write negative 5x times x minus 4 equals 0. Okay, which one? These two? Okay, so let's look at this next problem on the board. So negative 5x times a parentheses x minus 4. How can I make this guy to go to 0? How can I set this like the Titanic, make it sink? What values could I use? Maybe some of you guys already have it. Right? If you have it, go ahead and type in the chat. If you don't, let me write it out. If you don't want to write it as a public message, write it as a private message. You guys can always just privately chat me. Divide by negative 5. X is equal to 0. Plus 4, plus 4. X is equal to 4. Got it. Good job. Now, you could have done that right here. Because if you ever see a number, if you remember for algebra, that's by itself, that's going to be a free 0. That's our freebie. Now, what number cancels out with negative 4? Positive 4. Another freebie. You could avoid all those steps, all these steps, right? By just giving it another fresh look. Okay. What about that negative 5? What's negative 5 times 0? Still 0. Negative 5 doesn't matter. It's actually it's a distractor. Let's say that.